That dusty tower on the savanna is less a home than a breathing machine built by insects. Most of the colony lives below ground, while the mound above works like a giant ventilation organ. Down in the dark, termites farm fungus, a living food factory that only survives inside a narrow comfort zone. Too hot, too cold, too stuffy, and the fungus suffers, which means the entire colony loses dinner. So termites do something that sounds impossible. They build climate control out of dirt, spit, and teamwork. Inside the mound, tunnels, chambers, and vents turn random-looking mud into a carefully tuned airflow network. As the sun heats the surface, warm air inside starts to rise through taller internal shafts. That upward movement helps push stale, hot air away from the colony and out through upper vents. At the same time, cooler outside air gets pulled through lower passages and deeper underground corridors. The result is a steady exchange that helps flatten dangerous temperature swings across the nest. The walls matter too. Porous, pitted surfaces let gases diffuse while shielding the interior from harsh weather. So this isn't one big room, it's more like a natural HVAC system wrapped around a hidden city. At the heart of that city sit the fungus gardens, fed with chewed plant material delivered by workers. The fungus breaks that material down, turning tough leaves and wood into food termites can actually use. But millions of termites breathing, plus growing fungus, also means carbon dioxide can build up fast. Ventilation is not just about comfort. It's about dumping heat and clearing waste gases before they become deadly. Think of the mound like a chimney crossed with a lung. Heat rises, pressure shifts, air moves. Wind can help too, nudging air across the mound's surface and encouraging fresh circulation through tiny openings. Every ridge, pore, and channel changes how the mound breathes, like architecture shaped by physics. And termites keep remodeling it, patching holes, opening roots, and tuning the system as conditions change. Human engineers noticed this and started asking a bold question. Can buildings borrow the same trick? Some architects now use termite-inspired ventilation ideas to reduce air conditioning demands in hot climates. The goal is simple. Move more air naturally, burn less energy, and let the building do more work. What makes this wild is that no termite understands the whole blueprint. Each one follows local signals. A pellet here, a tunnel there, and thousands of tiny decisions become a working megastructure. That's called collective construction. Complex design emerging from simple rules repeated over and over. Season by season, colonies may seal, widen, or redirect passages as weather and internal needs shift. And not every termite mound works the same way. Different species solve the same problem differently. So the famous mound isn't just a pile of mud, and it isn't simply a bug apartment. It's a living interface between underground biology, outside weather, and non-stop insect engineering. No electricity, no blueprints, no foreman. Just evolution refining airflow over millions of years. The deeper you look, the stranger it gets. A farm, a nursery, a fortress, and a breathing machine. Even now, scientists still debate exactly how every mound balances heat, humidity, and gas exchange so well, which makes termites more than builders. They're tiny, experimental architects, still teaching us new tricks. So, here's the comment test. Would you trust a termite-designed office tower to cool itself in summer? If this changed how you see the natural world, like, subscribe, share, and tap thanks for more. Because sometimes, the smartest air conditioning system on Earth is the one hidden inside a mound of dirt.